Hi everyone, I am Anastasia Litou from Agricultural University of Athens and thank you for attending my presentation. Okay. The topic of this presentation is the investigation of the microbiological quality and safety of farm edible seaweeds Alaria esculenta and Saccharina latissima obtained from Scotland in 2 different years. A few words about seaweed production, which has been tripled from 2000 to 2018, while a slowdown in growth rates has been observed in recent years. However, new aquaculture practices such as integrated multi-trophic aquaculture could enhance again seaweed production and marketing. Regarding safety of seaweed, among several hazards, pathogenic bacteria such as Salmonella bacillus, pathogenic E. coli, Listeria, Staphylococcus, or pathogenic Vibrio could be considered as a significant hazard for these products. But how about microbiological quality and shelf-life? Seaweeds are characterized by high nutrient content and high moisture, which render them highly perishable products. However, few studies have focused on the microbiological quality of edible seaweed. The aim of this study was the investigation of the microbiological quality of fresh seaweed belonging to species Alaria esculenta and Saccharina latissima both after harvest and after storage at different temperatures. The microbiological quality assessment of dried and rehydrated products, the evaluation of the differences in the microbial load and profile between 2 different harvest years, examination for the presence of human pathogens. For this reason, we collaborated with Scottish Association for Marine Science, where samples cultivated and harvested 2 different species of 2 different harvest years, 2019-2020, in 2 different conditions, fresh and dried. Samples sent to the Laboratory of Food Microbiology and Biotechnology of Agricultural University of Athens, and the received samples, fresh, dried and rehydrated, were stored at different temperature conditions for a specific time intervals, and microbiological analysis were performed on the arrival of the samples at the lab and at certain time points throughout storage for the estimation of several spoilage bacteria, hygiene indicators, and pathogenic bacteria. Now I'm going to present you the results of this study regarding 2019 samples. In Alaria, the initial microbial population was at the level of 7 log CFU per gram, which is within the range for the onset of spoilage. The total viable counts exceeded the level of 8 log CFU at the 3rd and 1st day of storage for the product stored at 7 and 15 degrees respectively, while in Saccharina, the initial level of total viable counts was lower, 4 log CFU per gram, and reached the level of 7 log CFU per gram at the 4th and 2nd day of storage for samples stored at 7 and 15 degrees respectively. Temperature was found to be also as expected and the most influential parameter affecting microbial responses, and the growth rate was higher at 15 compared to 5 degrees. Regarding 2020 samples, the initial microbial load was close to the enumeration limit in Alaria. Completely different profile for 2019 samples. At 0 degrees, populations did not exceed 4 log CFU per gram even after 10 days of storage. The spoilage threshold, 7 log CFU per gram, was reached between days 4 and 6 for samples stored at 10 and 15 degrees, and day 7 for samples stored at 5 degrees. An important finding of this study was the high growth rate of total viable counts in these products, with an increase up to 3 log CFU per gram within a day, like we can see here, or here, and here. Concerning Saccharina, no specific growth pattern was observed, but only fluctuations in microbial population. For samples stored at 0 degrees, the microbial population was at the level of 2 log even after 60 days of storage, while no presence of Vibrio, Salmonella, Listeria monocytogenes was recorded. Also, Pseudomonads, Enterobacteriaceae, Bacteriophage Enterobacteriaceae family, Bacillus, gram-negative Aeromonas, and yeast and molds were below the numeration limit. This is a summary of the results I presented you before. This completely differentiated profiling products of different harvest years could be attributed to different time period of harvest, different environmental conditions, temperature and salinity, and different treatments and handling of samples after harvest. Regarding dried products, 2019 samples, the total viable counts were at high levels. Also, there was an increased load of bacteria from the Enterobacteriaceae family, which is a hygiene indicator, but also a decrease in microbial load was recorded after 6 months of storage. 2020 samples were products of high microbiological quality, really low microbial population. These differences were probably due to different procedure in handling the samples after harvest, controlled temperature conditions, and quick transfer of samples indoors, and of course due to lower microbial initial microbial population, lower microbial population in fresh samples. As far as rehydrated samples is concerned, the initial population of rehydrated samples was 1 log lower than dried samples used for this treatment, while the increase in temperature from 4 to 12 degrees increased the growth rate of microorganisms. Regarding the safety of seaweeds and the pathogenic bacteria, Salmonella, E. coli, and Staphylococcus aureus were absent in the tested samples, while Listeria monocytogenes was found to be present only in Alaria 2019 samples. Vibrios isolated for several samples, but further analysis is required to examine if these isolates belong to pathogenic species. To sum up, microbial load of both seaweed species was remarkably differentiated between 2019 and 2020 harvest, and further investigation of the factors affected this is required. Almost none of the tested specific microorganisms followed the growth of total viable counts, and further analysis again are needed to find out the dominant microbial groups and those associated with spoilage. Storage of samples at 0 degrees can significantly delay microbial growth and increase the shelf life more than 10 days in Alaria and 60 days in Saccharina. Quality of dried products is strongly related to the quality of raw material, but also to the drying conditions of post-harvest treatments and packaging. Initial microbial load of fresh samples can be considered as a critical parameter for the quality of dried and rehydrated products. The presence of Listeria monocytogenes in dried products probably was due to post-drying contamination, and seaweed microbiological quality could be standardized by taking into consideration factors such as environmental conditions, harvest time, and post-harvest treatment. This work has been supported by Project IMPAQT. And thank you very much for your attention.